Missing values are where people get lazy first. If you don't know why a field is missing, you're already guessing. I'd rather see explicit nulls than some heroic fill strategy nobody can defend later.
Depends. If it's random, nulls are fine. If it's systematic, you can poison the whole model with a neat little lie.
Exactly. I like to split it. Truly absent, not applicable, and failed to capture. Those are 3 different problems wearing the same mask.
Most pipelines don't.
Most pipelines are held together by optimism and a cron job. For numeric stuff, median imputation is boring but solid. For categorical, unknown beats inventing a fake majority class.
Unless unknown becomes the most common category. Then it's just a tax on bad logging.
Fair. Wise. Also, don't impute a target unless you enjoy explaining yourself to compliance.
And time series? Forward fill can be dangerous.
Yeah, because yesterday's truth is not always today's truth. I've seen a missing sensor value turn into 3 days of confidently wrong predictions.
I hate that kind of bug. It looks clean.
Clean data can still be dishonest. Better to flag missingness as a feature sometimes. The absence can be predictive.
Only if you track it consistently.
That's the whole game, really. Make the missingness visible, keep the logic simple, and don't let one clever fill method turn into a religion. And once the missing values are under control, outliers are the next trap. People see a weird point and immediately want to delete it. Like that fixes reality.
Sometimes it does. Sometimes it just hides the problem.
Right. First question is whether it's an error or a real extreme. A bad sensor spike is not the same as a rare customer with a huge order.
The context matters. I usually check against source logs and recent distributions before touching anything.
Good. Wah. If it's a legit extreme, I'd rather cap it, transform it, or use a robust model and throw away signal. Windsorization can be handy, but it's not a miracle cure.
I've seen people clip everything and then wonder why the model stopped caring about high-value cases.
Exactly. And in some datasets, the outlier is the story. Fraud, failures, edge cases, that's where the interesting stuff lives.
But if it's just one broken import, I want it gone.
Sure, but document it. Otherwise, 6 months later, someone will rediscover the same mystery and call it a data drift issue.
Or a feature. People love rebranding mistakes as features.
Happens all the time. The trick is to treat outliers differently depending on whether they're noise, rare truth, or a sign your pipeline is lying to you. Once the outliers are handled, scale starts mattering a lot more. If one feature is in dollars and another is in milliseconds, some models get very dramatic about it.
Especially distance-based ones. NaN-K means anything with regularization. They behave differently if one column is huge.
That's where people mix up normalization and standardization. Normalization usually means rescaling to a fixed range, like 0 to 1. Standardization means centering and scaling to mean 0, unit variance.
I know. The naming is annoyingly inconsistent across teams.
Annoyingly inconsistent across textbooks, too. I lean toward standardization for most cases because it preserves shape better when the data isn't nicely bounded.
Normalization can be useful when you need fixed ranges, like image inputs or some neural nets.
Yep, B. And you don't fit the scaler on the whole dataset unless you enjoy leakage with your coffee.
Training only. Why?
Training only. Then reuse it on validation and production exactly the same way. The subtle part is checking whether the distribution shifts later, because a scalar is not a one-time charm against chaos.
Especially if the data keeps drifting.
Which it does, because systems are rude like that. And once the scale is sorted, Categorical variables are the next place people get themselves into trouble. Strings look harmless until a model starts treating them like numbers with opinions.
One hot is the usual safe choice.
Safe, yes, but not always small. If you've got hundreds of categories, one hot can blow up the feature space fast.
Then you get sparse matrices and memory complaints.
Exactly. For high cardinality stuff, target encoding or frequency encoding can help, but you have to guard against leakage like it's a live wire.
Cross-validation inside the encoding step. Otherwise, you're just teaching the model the answer.
Right. And ordinal encoding only makes sense when the order is real, not when somebody just wants the columns to stop being text.
I've seen people encode cities as 1, 2, 3, and call it a day.
Classic. Then the model thinks Paris is somehow greater than Tokyo.
It is if you're measuring rent.
Fair, indeed. But if the category has meaning beyond identity, maybe there's structure worth preserving. Otherwise, keep it explicit and boring. Boring is good in preprocessing.
Boring and correct.
Best combo we've got. After encoding, I usually check for duplicates. People underestimate how often the same record sneaks in twice.
Especially with batch imports and retries.
Exactly. A duplicate can make a small cohort look twice as important as it is. That's not just noise, it skews counts, rates, and training examples.
But you can't always just drop duplicates blindly.
No. Some are true duplicates. Some are repeated events. And some are near duplicates that look identical until you inspect the timestamp or source ID.
I usually define a key first. If the business says 1 row per customer day, then that's the duplicate boundary. Otherwise, we're guessing again.
Good rule. And if 2 rows differ only in a late arriving field, you need a merge policy, not a deletion policy.
The worst is when duplicates hide upstream bugs.
Oh, absolutely. I've seen retries from a flaky API create 3 copies of the same order, and everyone blames analytics because the dashboard got weird.
The dashboard always gets blamed.
Because dashboards are innocent and easy to accuse. But yeah, dedupe carefully. Log what you removed, and make sure you're not deleting legitimate repeats just because they're inconvenient.